As we begin our study of the ocean application, let's look at the serial program. The equation solver solves a PDE, that means a partial differential equation, on a grid. The grid is rectangular and it's n plus 2 by n plus 2 elements. Why n plus 2? Because the boundary elements, which are the 0th column and row and the n plus 1st column and row, do not change. They're boundary elements. All that changes is the n by n grid within. The interior points are updated starting from their initial values. And notice that the equation that we're solving here averages the current value of a point in the value of all four of its neighbors above, below, and on either side to form the new value of a point. The old value is replaced by the weighted average of itself and its four nearest neighbor points. Updates are done from left to right and from top to bottom. So our doubly nested loop goes through the elements in this order. The update computation for a point thus sees new values of points above and to the left. Those are the values that have already been computed. And it sees old values of points below and to the right. This form of update is called the Gauss-Seidel method, because it uses certain updated points and certain old points in the calculation. There's also the Jacobi method, which uses all the old values of the points, but it converges slower, and it's also a little bit more complicated to compute because you've got to keep a separate copy of the old values, so we'll use Gauss-Seidel. During each sweep, the solver computes how much each element has changed during the iteration. If the difference is less than a tolerance, the solution has converged. And actually the way it does it is to take the overall difference between the new points and the old points and divide it by n times n, which is the number of points. So if the solution has converged, we exit the solver. If not, we do another sweep. Let's look at the code for the solver. The code starts off by declaring the array and initializing diff to 0. And then it reads in the array, it reads in the value of n and allocates space for the array in memory. Then it initializes the array based upon the initial values of the grid. It solves for a, that calls the procedure below, and then it exits. The solve procedure is essentially a triply nested loop. The outer loop is a while loop that determines whether or not the solution is converged. And the two inner loops iterate over the rows and columns of the grid respectively. And all they do while they iterate is to update values and then add the difference between the old and new values to the running sum of differences. You set the old value to temp, and then you use temp in computing the difference. And then after you get done with the two inner nested loops, you check for convergence by determining whether diff divided by n squared is less than tolerance. And if so, you exit. Otherwise, you continue through the loop.